Questions 13 and 14 have to do with solving inequalities. And so the important things to remember about solving inequalities is that for the most part they're exactly like equations, but there's one major exception when it comes to solving. When it comes to solving, whenever you multiply or divide by a negative value, you're going to switch the direction of the inequality. So we'll be on the lookout for something like that when we solve these. I'm going to rewrite these over to the side. So I've got negative 3 times the quantity 2 plus 3n is less than or equal to negative 33. And I'm going to distribute my negative 3. I could have also divided by negative 3 on both sides, but I'm going to go ahead and distribute and get negative 6 minus 9n is less than or equal to negative 33. Now I'll add 6 to both sides, and I get that negative 9n is less than or equal to negative 27. And then I'll divide by a negative 9. And at this stage, I have to pay attention to what I'm doing because I'm dividing by a negative number. So then I'm going to switch the direction of my inequality. N is greater than or equal to 3 is my solution here. N is greater than or equal to 3. Then I want to graph that information. The or equal to tells me that there should be a closed dot here at 3. And I want things that are greater. And so I always use a test point to help me out with that. If I plug in 0 here, is 0 greater than or equal to 3? No. How about 7? Is 7 greater than or equal to 3? Yes. So I can shade this direction on my number line. The last piece to pay attention to is the interval notation. And so if I read my graph from left to right, the first place I have a solution is at 3, and 3 is a possible solution, so I'll put a bracket by it. And then the graph here goes on forever in this direction, so it actually ends at infinity, which isn't a thing, isn't actually a number, and so since we can never actually reach it, we would put a parenthesis there. Put a box around that as well. So I have a solution, a graph, and my answer in interval notation. We can do the same kind of thing for number 14, so let me rewrite it. 2x plus 6 is greater than 7 minus 3x. The first thing that I would do is add 3x to both sides. I get 5x plus 6 is greater than 7. Then I would subtract 6, 5x is greater than 1, and then divide by 5. So my answer is going to be that x is greater than 1/5. At no point did I multiply or divide by a negative value, so I never switched the direction of my inequality. Because there isn't an or equal to here, I'm going to put an open dot at 1/5 on my number line. They helped us out with that by already putting the numbers on there. And I want to find numbers that are bigger than that. So I'm going to use numbers that I feel comfortable with, like 1. Is 1 greater than 1/5? That's certainly true. So I'm going to shade towards that solution. And so again, to write my answer in interval notation, I will start on the left side and read my graph from left to right. The first place where we have a solution is 1/5, but because it has an open dot, 1/5 isn't actually a solution, so we use a parenthesis. And then our solutions continue on forever to the right and go on to infinity. And again, infinity is not something you can actually reach, so we'd use another parenthesis, interval notation. Open dots go with parentheses, closed dots with brackets. The most important thing to remember when you're solving inequalities, though, is that when you multiply or divide by a negative number like we did here, you should switch the direction of your inequality.